Ladies and gentlemen, first of all I want to say thank you for enrolling in this course and I want to welcome you. I hope that this will be an interesting journey for every student. Before beginning with anything, there's something that I want to get out of the way. Since this course is meant for anybody from beginner to advanced, that means that not every student will have the same learning pace. Therefore, we try to speak as slowly as possible without sounding bored or sleepy. However, if you do not prefer the slow way of learning things, Udemy has you covered. You can adjust the speed by clicking the speed multiplier in every video, and you can set it to 1.25 if you prefer a bit quicker lessons. However, if you had too much coffee this morning, you could also try the 1.5 multiplier. Now that we have that out of the way, we can talk about the curriculum and show you the finished product of the game before beginning. The first section, of course, is the introduction section, and right now we are watching the only video of this section. However, that doesn't mean that we will not be adding more videos to this section in the future. If students request something to be explained before beginning with the games, it will be located in this section. Moving on, the next section is reserved for the first game, which is the color switch game that looks like this. You might notice that this is the longest section, with 32 lectures. But we have a very good reason for doing this. During the first game, students will be faced with many new things in Unity and game development. And we will take our time to thoroughly explain those concepts. There are also some special lessons in this section, which are not directly related to this game, but are more like a general knowledge about Unity and how things work in Unity. After that, we have 3 more sections reserved for each game. They are all similar in length. First, we have the AA game, which looks like this. After that, we have one section reserved for the Flappy Bird replica game, which looks like this. And finally, we have one section reserved for the Dino T-Rex replica game, which will be looking like this. Please note that in the future there will be more sections created when we decide to add more games or bonus lectures to the course. Another very important thing that we need to do before we begin with any actual game development is to download the necessary files. I have hosted the files on my website, which is right here, supplyspace.net. And if you go to the home screen, you can find files for the various games that you'll need to create, such as the T-Rex right here. This is the complete Unity project, and these are the necessary files for it. The same thing again for Flappy Bird, the project, and the files. Here we have the AA replica, project and files, and finally we have the project of the color switch game and the necessary sprites. In order to download them, all you need to do is click on this link. As it says, click here to download all the sprites that you need to create the color switch replica game in Unity. If you click there, your web browser will start downloading it. And once that is done, open up the folder to where you set it to download files. And you can see that the files are in a zip format and you need to extract them first before usage. That means you will need to use WinRAR or 7-zip or something like that. So just right click it and choose extract here if you are using WinRAR as me. And after that you can see all the files that you need in this game. Do not worry about the website, it's virus free, you don't need to sign up for anything, you don't need to leave your details, there are no ads on this, it's completely free. If you are having trouble with finding all of these files, you can use a search and, for example, type in color switch, and it will automatically find the files that you are looking for. If you are having trouble of getting a link to the site, you can simply open up my Udemy profile, and below my picture there should be this little icon. If you click, it will take you to my website, where you can find the files. And that's everything that we needed to do before we can start making our games. See you in the next lesson. Welcome back, ladies and gentlemen. This lesson will be all about adding the functionality to the obstacle. First off, we need to select all of the obstacles, and they need colliders, so go ahead and click Add Component, Physics 2D, and the only collider that will kind of work for this shape is the Polygon Collider 2D. We also want to make every of these colliders a trigger, so go ahead and check the Is Trigger option to enabled. After that, we will need to create a script, so right click on our scripts folder, go to Create, C# script. And we can name this script Player Collision. Open it up in Visual Studio. This is a script that will be attached to our player game object, and it will check for every collision that our player makes. That means it will not only be usable for the colliders, but also for collecting points and changing colors later on. Since we want to check for collision, we won't be using these two methods, but instead we'll be using the onTriggerEnter2D method. First off, whenever our player object collides into something, we want to check whether that object is the obstacle. We do that using an if statement. So if collision.tag equals to obstacle, then we want to execute the code between these two brackets. Just to make space for future editing, let's write a few more comments. If the object that our player has collided with is not the obstacle, maybe it is the point. So let's write a comment here that will indicate where to write our code later on. And maybe one more. For now, we will only be building this part of the code. Whenever our player game object collides with an obstacle, we want to check which obstacle that is, since we have 4 different obstacles named after their color. And now you can kinda see why we changed the name of our player game object to represent its color as well, because it's much easier to check whether the names match than to check whether the colors match. If our player game object is red, it won't be called player anymore, it will be called red instead. And the obstacles are called after their color as well. So if the name of the obstacle and the name of the player matches, we won't do anything, but if it doesn't match, we want to load the game over scene. To check whether it doesn't match, let's write another if statement inside of this if statement. We have already determined that the object is an obstacle, and then we want to check if collision.name is not equal to the name of the player, this being the name of the obstacle and this being the name of the player. This simply means it's not equal. Then we want to execute this code between these brackets, and to change the scene we need to implement the scene management. To do that, type using Unity engine.scene management. And now we can use the scene manager. Scene manager.load scene, and the name of the scene is game over scene, if I remember correctly. Make sure you save this, and also don't forget to add it to the player object. Let's see if it works. Yep. If we pass through the yellow with the yellow object, it should be fine,
but if we touch any other color, it should take us to the game over scene, which is empty right now, so that's why it's all blue. That's it for now, and see you in the next lesson. Welcome back once again, ladies and gentlemen. This is going to be a quick lesson about instantiate and prefabs in Unity. In our case, we'll be cloning the obstacles and some other objects later on. The objects that will be cloned are called prefabs. And what a prefab is, it's simply any game object in Unity that we want to save and use as an asset later on. For example, we can have this small circle become a prefab by selecting the game object and dragging it into the prefab folder. It will be listed with a blue cube next to its name, which is the icon for the prefabs. And all the options that we set here before will be saved once we drag it into the assets. Let's see how the structure of the instantiate function looks like. To do that, we'll be creating a new C# script. So right click on your script folder, go to create C# script. And we can name it Obstacle Cloner. Double click it to open it up in Visual Studio. The instantiate function takes 3 parameters, so this is what its structure looks like. First we have the name of the function, and inside of the brackets we are going to have 3 parameters separated by commas. The first will be the prefab that we want to instantiate, or in other words, it will be the object that we want to clone. The second parameter will be the location of where we want to put that cloned object. And the third parameter will be just the rotation, or how we want that clone to be rotated. Of course, this is just an example and it doesn't do anything at this moment. I just wanted you to see how an instantiate function looks like. We can go ahead and delete this right now, and in the next lesson we'll see some practical use of this function. Welcome back, ladies and gentlemen. Since we learned a bit about instantiate and prefabs, let's put it to use in our project and see how it actually works. First off, we have created the prefab from this game object, but we are going to make some changes to it, and we will need to save those changes as well later on, so we can delete this from our prefabs right now. Select it and press delete on your keyboard. It will ask you to confirm since this action cannot be undone. However, we are going to leave this script for now and we are going to use it later on. It doesn't do anything at the moment, so it's okay that it stays here. In order to clone our obstacle game object and make it spawn at a certain location, we'll need 3 things. The first thing is an event, the second thing is a script, and the third thing is a spawn location. The event is simply a trigger for the script to tell it when it should start creating a clone, and the spawn location is the location of where we want that clone to be located. Let's start with the event first. We can create an event by using triggers just like we did in the previous lessons. We can select the small circle, add component, physics 2D, and add a circle collider to it. Please note that this is still a collider of the small circle game object, and since we don't want it to interact with other objects, we just want to create an event, we can drag it all the way to the left by adjusting the X offset. But maybe some of you already noticed the problem with this one. Since this game object has the rotate script attached to it, it will make this circle also rotate around the center point. So if we click play, it won't be as we meant to be. Therefore, let's remove this component from the small circle game object. To do that, right click on the Circle Collider 2D and choose Remove Component. What we can do to fix this problem is right click in the Hierarchy tab and create an empty game object. We can name it small circle holder. Make sure to reset the positions first. And after that, simply take the small circle game object and drag it into the small circle holder. That will make it the child of the new game object. So now we have the small circle game object that will rotate and the small circle holder which won't rotate. So we can add a collider to this one. Click on Add Component, Physics 2D, and add a Circle Collider 2D. Set the X offset to -8 and enable the Is Trigger option. We can also adjust the Y offset to make it parallel to the obstacle. 2 should be fine. And let's also add a tag to this. And we can name the tag Spawn. Click on Save and make sure you go back to the game object and select the tag. However, one trigger doesn't make an event, so we'll need another one. The second trigger will be attached to the half screen game object. Click on Add Component, go to Physics 2D and add a Circle Collider to it as well. We also want to change the offset in this one as well to -8 and Y to about -5. If we select the small circle holder and hold Ctrl on our keyboard and select the half screen, we'll be able to see both of these colliders. So when they bump into each other, we'll take that event and execute the script. Let's see how it actually works. So when the camera goes up, it will take the half screen with it and eventually the triggers will touch. And when they touch, we want to create a clone. Everything looks good, except I would like to change the half screen Y offset to about -4. Okay, so now that we have a usable event, we will use the obstacle cloner script to check for that event, and that script will be attached to the half screen game object. So first open it up. Once it's open, we can delete these two methods, since we'll be using the onTriggerEnter again. So go ahead and type private void onTriggerEnter2D, and we want to check whether the trigger that has entered is the spawn trigger. We will use an if statement, so if collision.tag equals to spawn. Then, if that is the case, we want to clone the obstacle object. And with that, we are getting to our second point, the script. So we will be using the instantiate function. And as we learned, the first parameter is the prefab that we want to instantiate. Since we deleted our prefab, let's create one again. Take the small circle holder, since this is our new object, and drag it into the prefabs folder. Then let's go back to the script, and we need a way to select that prefab and use it in this script. So we need to create a public variable. And it's going to be a variable of type GameObject, and we can call it small circle prefab. That's the object that we want to clone, so let's use that parameter. Next, we'll need a location and rotation for our clone game object. And that takes us to the third point. We could type in the coordinates, but a much easier way to do this is to create an empty game object, and we can use the location of this game object as a spawn point. Let's reset the positions real quick. And we can name this object small circle spawn. Make it a child of the half screen, and then move it into the location where you want the small circle to spawn once the event triggers. we'll probably need to do some testing to determine where the ideal location is, but let's set it to here for now. Go back into the script, and we'll also need a way to reference that location, and therefore we'll create another public variable. It's going to be of the type GameObject again, and we can call it small circle spawn point. So the next parameter is the position. So just type in the reference, which is small circle spawn point, and to get the position we need to type in dot transform dot position. And the final parameter is rotation. It is the same thing as with the position, but instead of position we'll write rotation. So we can go ahead and copy this and just change the position to rotation. Save this and let's see if it works. Don't forget to attach the script to the half-screen GameObject. And before we start we need to attach these GameObjects here, because we can see that none are selected for now. To do that, simply drag and drop it into this area. So for the prefab we need to take this and drop it here, and for the spawn point we need to take small circle spawn and drag it into this area. If we click play, we should see another obstacle pop out when we trigger the event. And this should allow us for an infinite game. The only problem right now is that these obstacles are too far apart, but that's very easy to fix. We just need to take the small circle spawn point and drag it down. As we can see, it's much better now. But if we play for a while and then click pause, we can notice that we have these obstacles staying there and not getting destroyed after we are done with them. We'll need to find a way to destroy them so that they don't take too much hardware resources of our phone, since this game is going to be infinite and some people are very good at it. We'll be doing that in the next lesson, stay tuned. Ladies and gentlemen, welcome back. As promised, in this lesson we'll be making some GameObject that will get rid of the other GameObjects that we don't need anymore. To start off, simply right click in the Hierarchy tab and choose 2D Object Sprite. We are going to name this sprite Destroyer. And let's assign it a tag that says Destroyer as well. Don't forget to go back to the object and assign the tag. And make sure you reset the positions to 0 before you do anything. Now this sprite will not actually have an image since we want it to stay invisible, but it doesn't matter since it will be out of view anyway. We are going to drag it down to about -10. And let's add a collider to it. Click on Add Component, Physics 2D, and choose a box collider. We can't see the collider yet since there's no image, so we need to expand it manually. Change the size in X and in Y. So this is a GameObject that will be floating up along with our camera, and everything that touches this will be destroyed. That way we'll get rid of those unused objects and the game will not be using too much hardware resources, so the performance will be good. We'll need a new script to deal with this, so right click on our scripts folder, create C# script, and we can name it Destroyer. Open it up, And as you might have guessed, we'll be using an onTriggerEnter2D method for this. So we'll go ahead and delete these two methods. Also, before we forget, go back to Unity, select the destroyer object and make sure the collider is set to a trigger. So type in private void onTriggerEnter2D, and this is going to be a very simple script. Everything that enters this collider will be destroyed. To destroy a game object, simply type destroy, and inside of the brackets should be the game object that we want to destroy. To get the game object, simply type in collision.gameObject. And it's as simple as that. Make sure you save it, and also don't forget to attach it to the destroyer. Take the destroyer game object and make it a child of the half screen so that it follows the camera. It should be fine now. If we pause now, we can see that there are no unused objects left behind, and that's exactly what we wanted to do. Another thing that I don't like is that the circles spawn too far apart, so let's adjust the spawn point a little bit. Simply take the small circle spawn game object and drag it a bit more down. Let's try it out again. This seems much better, to be honest. Welcome back, ladies and gentlemen. In this lesson we will be focusing on creating some more obstacles, because a game with only one kind of obstacle is kinda boring. We will also be editing the script that spawns the clones, so that it spawns one random object from our pool of obstacles. Let's start by creating one obstacle from the sprites. Open up the Place Scene Sprites in the Sprites folder and find these 4 sprites. Drag them into the scene individually. First, we want to rename them so that their names represent their color. The same thing that we did with the circle obstacle. So this is going to be yellow, red, cyan, and magenta. The next thing that we want to do is select all of them and change the scale to 0.5. While they are all still selected, we can go ahead and assign an obstacle tag to them. It's a tag that we already created. We can also click on Add Component, Physics 2D, and choose Capsule Collider 2D. We can see that the yellow and cyan one turned out fine, but the red and magenta one are really weird. So select them and in the direction change it from vertical to horizontal, and they will be fine as well. The next thing that we want to do is to assemble them properly. Again, we want them to be close together, but we don't actually want them to be touching. Make sure to select all of them again and check the isTrigger option to enabled. Once you are happy with the result of positioning them, you'll need an empty game object like in the small circle and a holder like the small circle holder. So let's not waste time by creating them again. We can just click on the small circle holder and press Ctrl+D to duplicate it. And once it's duplicated, select these obstacles and delete them. Next thing that we want to do is to drag this down so the circle obstacle is parallel to this. And then we want to select these obstacles and drag them into the small circle that we copied. Then we can rename it to small rectangle. And we can also rename this to a small rectangle holder. Once you are happy with the result, make this into a prefab. Simply select it and drag it into the prefabs folder. Then we can go ahead and delete it from the starting plate. Now we have two different kinds of obstacles, but the script that's spawning them will actually just spawn the circle right now, so we need to edit it. That script is called the obstacle cloner. Open it up in Visual Studio, and once it's open we want to add two new variables. They are also going to be public game objects. The first is going to be the small rectangle prefab, and the second one is going to be the small rectangle spawn point. This part of the code will actually be the same, but the only thing that we need to do is to introduce a new random integer value. So we are going to have an integer called ran, which equals to random.range, and inside of the brackets we want to start from 0, including 0, up to the number of obstacles that we created, which is 2 at the moment, excluding 2, which means this value can either be a 0 or a 1. So that will give us a 50-50 chance to spawn one of the obstacles that we created. It's the same trick as we did in the color change at the beginning. So if this value is 0, we want to go ahead and spawn the rectangle. Don't make this foolish mistake aside, make sure you have two equal signs. And we'll write a small comment here indicating that this is a circle. If it's not 0, we could simply just type else, but since we are probably going to add more obstacles later on, let's type else if ran equals to 1. Then we'll be instantiating another object, which is the small rectangle prefab at the small rectangle spawn point location with .transform, .position, and the rotation will also be small rectangle spawn point .transform, .rotation. Make sure you save it. We have already assigned the script to an object, but we didn't assign the new variables that we introduced. To do that, click on the half screen game object and find the script that we attached. We can see that the small rectangle prefab and the spawn point are empty. So first we'll need to create a spawn point because we don't actually have one. We can just duplicate this one by Ctrl+D or Command+D on Mac, and we can rename it to small rectangle spawn. And we want to move it a bit up. So now click on the half screen again to assign the variables. In the prefab, drag the small rectangle holder, and in the spawn point, drag the small rectangle spawn. If we click play, it should work properly now. Welcome back, ladies and gentlemen. This will be a lesson about changing the player color after it hits the color changer object. We will be creating the object and editing an already existing script so that it gives it functionality. And trust me, it's much easier than it actually seems. So first off, right click in the hierarchy tab to create a new 2D object and a sprite. Let's immediately rename the sprite to color changer. Let's go ahead and assign a tag. Click on add a tag and add a tag called color changer as well. I have already done that, I'm just showing you, and make sure you go back to the color changer object and select that tag. Also make sure to reset the positions first. And then in the sprite renderer tab we want to choose an image. Click on the little circle and choose this image. That's an image that I already prepared. Double click it. And since it's too big, we want to change the scale to 0.25 and again 0.25. We also want to change the sorting layer to foreground, and that's the sorting layer that we created in one of the first lessons. Another thing that we want to do is we want to add a collider to this. So click add component, physics 2D, and choose a circle collider 2D. Make sure you check the ease trigger option. And that's basically everything that we need to do about this object. It's going to be a prefab, but we won't save it yet because we want to do some testing and see if it actually works correctly. We want to be creating a new script because we already have a script attached to the player game object that handles the collisions, and it's called the player collision script. To open it up, simply right click it and choose edit script. Once it's open, you can see that we already wrote comments before indicating where to write the next code. But since we are handling the color changer before the point, let's go ahead and switch these comments quickly. Just so we don't get confused later. So we already have an if statement that's checking whether the player collided with an obstacle. And if that's true, it will execute this code. So if it's not true, then we want to check whether it collided with something else. So else if collision dot tag equals to color changer, then we want to execute some code that will change the player's color. And we have already handled some similar code in a script called player start color. So let's open up that and check it out. Right click and choose edit script. Just as a reminder, we had a random value between 0 and 4, excluding 4, and depending on which number we got, we would change the player's color to some of these 4 colors. So let's go ahead and copy this code. We can paste it here, but we will be editing it. First off, we can see that we are missing the player sprite variable, so let's go ahead and add it at the beginning. It's going to be a private variable. The type is going to be sprite renderer, and let's call it player sprite to keep the same name. Also a kind reminder that this is a script that's attached to the player game object. So we are introducing the variable here and we are assigning the value here. We'll need 4 different if statements inside of this else if statement. We'll check whether the player is yellow. We'll have a certain code. And we'll have one for every color. Trust me, these comments can be a lifesaver sometimes. So we can see that we are introducing the random variable before we even know which color of the player it is. But we shouldn't do that. So let's go ahead and write some if statement for these different variations. So if name equals to yellow, that means the player is yellow. And we can get the name simply by typing name, since this script is attached to the player game object, as I said. Let's go ahead and copy this, since we'll be writing it 4 times. Instead here will be red. Make sure don't make any typing mistakes, because that's absolutely crucial here. And we won't be introducing the random variable before we know which color it is, so let's go ahead and cut this, paste it here, and now we can go ahead and copy it to every single of these. And now we can go ahead and cut this. Paste it here. And since the player is already yellow, in this case, we'll be getting rid of the case 1 completely. And we'll rename this to be case 1 and this to be case 2. So every single set of these codes is going to be only 3 cases, because 1 color will be missing. And we need to reduce the range to 3. So it's either 0, 1 or 2. And before I made the mistake, make sure you change these if statements after the first one to else if. Let me go back into the other script to copy the code again, but this time we won't be needing the int variable. So just copy the switch statement, paste it into the red, and again it's going to be from 0 to 3, and we are going to eliminate the first one. Don't forget to change the names of these cases. The code is already copied on my clipboard, so I can go ahead and paste it here in the cyan, and we are going to eliminate the last case and reduce this range to 3. And once again the same procedure, except this time we'll be eliminating case 2, 0, 1 and 2, and reducing the range again. Save this, and let's see if it actually works. So our player shouldn't be able to get the same color twice, which seems true. So everything seems fine, except we need the color changer to be destroyed once the player changes the color. And that's very easy to do. Just go back into the script. And the first thing that you want to do, if you determine that the collision is with the color changer, is you want to destroy the object that you collided with. And that is the color changer as we determined. To do that, we are going to use the destroy function once again. Destroy collision dot game object. And it's as simple as that. Make sure to save it again. Go back to the Unity project. And let's see if it works. Yep, that's exactly how we wanted it to be. What we want to do next is to change the position of this color changer, since we want it to be after the obstacle. Somewhere around here. And we also need to make it into a prefab. To do that, simply drag it into the prefabs folder. After that is done, we'll need a way to instantiate it. So first we'll need a spawn point. Let's just duplicate this by Ctrl+D and rename it to color changer spawn. And we want it to be a bit lower than the rectangle, so let's drag it all the way down. We can just use the half screen script that we use to clone the obstacles. So right click on it and go to edit script. And we'll need some new variables. Both are going to be public game objects. The first one is going to be color changer prefab. And the second one will be the color changer spawn point. So simply, whenever we spawn an obstacle, we want to spawn this color changer above it. Maybe we'll need to edit the location a little bit, but that's easily adjustable. So here's where we spawn a small circle, and I forgot the comment here, so let me fix that. And here's where we spawn the rectangle. So after we spawn the circle, we also want to instantiate the color changer. The prefab is called color changer prefab, and the location will be color changer spawn point dot transform dot position, and of course the rotation will be color changer spawn point dot transform dot rotation. And we are just going to copy this line of code for this case as well. Make sure to save it and let's see if it actually works. Oh, I forgot to assign the variables. Sorry. So go to your whole screen and find the script, and we can see that the color changer prefab and spawn point are missing. Simply take the prefab, drag it into the prefab area, and the spawn point is so let's see now. Okay, it seems to work, but the position is a bit tough, but we can edit that easily. Just need to move it up a little bit. Just take the color changer spawn and drag it to around here. Let's see how it works now. Okay, it seems fine now, just the only thing that I would like to change is to delete it from the starting play, since it will spawn automatically. Okay, this seems perfect. I told it's going to be way easier than you think. It might seem a little bit complicated with the many if statements, but when you think about it, it's really simple. Hello everybody and welcome back. In this lesson we'll be learning how to make the point game object that the player is able to collect and that looks like a star and is located in the middle of every obstacle. The whole process will be kinda similar to how we created the color changer. So the first part will be almost the same and the second part will be the coding, and that will be handled in the next lesson. So to start off, right click in the hierarchy tab, create a new 2D object sprite. We can name this sprite point, and let's assign a point tag to this object. So go ahead and click on add tag, click on the little plus and name it point. Save it and make sure once again you go back to the point object and select the tag. Then let's reset the positions. After that is done, we want to select an image in the sprite renderer. Click on the little circle and I have already prepared a star sprite, so double click it to select it. As usual, it's too big for our scene, so we'll need to scale it down. The X scale and the Y scale will be about 0.3. And since we'll have the original point object in the starting scene, let's drag it into position here. It will be on Y position 2, so we make sure it matches the center of the circle. Another thing that we want to do is to select the sorting layer. It's going to be the sorting layer that we already created and is the foreground one. Next, click on Add Component, Physics 2D, and add a Polygon Collider 2D to this game object. We can zoom in to see how it looks like. And this should be fine. It doesn't have to be perfect for now, since we don't want to waste too much time on this. And the final thing that we need to do is to make this Polygon Collider 2D into a trigger by enabling the isTrigger option. Once that is done, we can go ahead and save this as a prefab. Simply select it and drag it into the prefabs folder. That's it for the first part of making the point game object, and in the next lesson we'll be handling the code. So stay tuned. Ladies and gentlemen, thanks for tuning in again, and let's jump straight into the coding now. First off, we want something to happen whenever our player game object hits or collides with the point game object. We have already a script that handles the player collisions, and of course it's called player collision, so let's go ahead and open it up in Visual Studio by double clicking it. Once it's open, we can see that we already checked whether the player collided with obstacles, and then whether it collided with the color changer. And we also left a comment at the bottom to indicate where we should write the code in case the player collided with a point game object. So you can see how useful these comments can be. So we'll handle it just like before with an else if statement. Else if collision dot tag equals to point. And if that's the case, first off we want to add +1 to our score, but we didn't create a score text yet, so we'll also write a comment here to indicate where we should write the code later when we do. Once we add the +1 to score, we want to destroy the star object. And inside of the brackets we type in which game object we want to destroy. It's going to be collision.gameObject. so we'll still need to write this code later on. But let's go ahead and save this and see if the object will get destroyed, so we can be sure everything works as we want it to. Okay, seems fine, but there aren't any more of these stars spawning inside of the obstacles. The spawning of the obstacles is handled in the obstacle cloner script. Whenever we spawn an obstacle, we also want to spawn this star or point game object. Open up the obstacle cloner script, and once it's open we will need to add a new variable. That's going to be the variable that will hold the prefab of the point game object. So it's going to be public game object. Let's name it point prefab. We want to spawn the point at the exact same location where we spawn the obstacles, so we won't need a specific location for the point game object as we did in these. Therefore, this variable will be enough. So if we are spawning a small circle, we also want to spawn a point inside of it. To do that, in this part of the code, add another instantiate function. And this time we will be spawning the point prefab. However, the location and the rotation is going to be the same as for the circle. So we can just go ahead and copy this. Paste it here. And don't forget to close it up with a semicolon. Let's do the same thing in the rectangle piece of code. Instantiate point prefab, and this time the position and rotation will be the same as for the rectangle. So this time we'll be copying this and pasting it here. Again, don't forget the semicolon. And this code should actually be enough to handle the point game object. So go ahead and save all of this. And don't forget you go to the house screen and find the obstacle cloner script, since we need to attach the point prefab here. Find the point prefab in the prefabs folder and drag it into place here. Once that is done, let's click on play and see how it works. Okay, so now the point is in the middle. But what will happen when we get to spawn another one? It doesn't spawn in the right place, it spawns below the actual obstacle. And we don't want that to happen. The reason behind that is that we made a mistake while constructing these obstacles. Let's pause the game so I can show you which mistake we did. Expand our small circle holder prefab and select the small circle. We can see that the position of this game object is in the middle of the obstacle. However, if we select the small circle holder, it will be below the obstacle. And that's where we made a mistake. So to fix that, make sure you drag the small circle out of this. It will warn you about breaking the prefab, just click continue. And then we want to drag this small circle holder up, and the position should be 2 on the y-axis. However, now it also dragged up our 2D collider, so we'll need to fix that as well. Make sure you set the y offset to 0 in the Circle Collider 2D tab. Once that is done, it should be fine. Select the small circle again and drag it into the small circle holder to make it a child of it. And since this isn't a prefab anymore, we'll need to make it into one. But this one is the one with the wrong options. So make sure you select this prefab in the prefabs folder and delete it by pressing delete on your keyboard. It will warn you, but don't worry, just click delete. And then we can drag it into the prefabs folder to save it again. And this is the correct one. We will also need to do the same changes to the small rectangle holder, since we did the mistake there as well. To edit it, simply drag it into the scene, and the same process again. Expand it, drag the small rectangle out, break the prefab, and then we need to adjust these positions. I think it's going to be -1 on the y-axis for this. And we'll also need to adjust the y offset in the Circle Collider 2D tab. So 0 should be fine. Just make sure that this collider is parallel with the center of the obstacle. Once that is also fixed, take the small rectangle again and drag it into the small rectangle holder to make it a child of it. Then we need to do the same thing. Click on the small rectangle holder in the prefabs folder and press delete on your keyboard. Click on the delete button to get rid of this bad prefab. And now, since we are missing the small rectangle holder prefab, we simply create one by dragging this into the prefabs folder. And make sure you delete the small rectangle holder from the starting scene. Since we have edited these prefabs and they are in fact new prefabs that we created, we need to go back to the half screen, scroll down to our script, and we can see that the small circle prefab and the rectangle prefab are missing. So select the small circle holder and drag it into the circle prefab, and the rectangle holder, drag it into the rectangle prefab. Okay, now everything should be working fine. Let's see. The only issue now is that since we edited this, the obstacles are spawning too close to each other. So we will select both the small rectangle spawn and the small circle spawn by holding Ctrl and selecting them and drag it up a little bit. You can play with adjusting the position of these spawn points and finding the right position to spawn your obstacles in your game, but we'll not spend too much time doing that now, because it doesn't have to be perfect right now. The main thing that matters now is that we got the point game objects to spawn in the middle of the obstacles, and that's what we wanted to do. In the next lesson we will be making a score text in the top left corner that will display how many stars we collected. And we'll be editing the player collision script to make that number increment every time we collect a point. Welcome back, ladies and gentlemen. In the last lesson we made these game objects as stars that we are able to collect, and that's going to be our trigger for the score. But right now we actually don't have a text to display our score. In this lesson we'll be configuring that. There are two ways to do this. The first way is to create a 2D text, and the second way is to create a 3D text. 3D text is a lot simpler to handle, and since this text will not be interactive with the player or any other game object, it's okay for it to be a 3D object instead of a 2D one, even if this is a 2D game. To create one, simply right-click in the Hierarchy tab, choose 3D object, and at the bottom of the list you should find the 3D text. We can rename it to score. You might notice that our text is a bit blurry and low resolution. In order to change that, we need to increase the font size. So let's set the font size in the text mesh component to about 200. However, that will make our text look incredibly big. To reduce the size but keep the high resolution, we'll need to reduce the character size. It will be around 0.05. Reset the positions, and now drag it into place wherever you want it to be. I want it to be in the top left corner. Around here. Hello world is our starting text right now. We want it to start with a 0 since the player hasn't collected any stars yet at the beginning of the game. So change this text here to 0. Let's click play and see how it looks like. Okay, after the first play we can notice two things that need to be corrected. The first thing is that this text isn't following the camera. To fix that, simply take the score game object and make it a child of the half screen. and this will make it follow the camera up as the game progresses. The second thing is that it doesn't change the value from 0 to 1 once we collect the star. To fix that issue, we'll need to do some coding again. And that coding will be in the script that handles the player collisions, and that script is of course called the player collision script. So go ahead and double click on the player collision to open it up in Visual Studio. If we scroll down at the bottom of this script, we can see that we made place for that code indicated by our comment that we made in the last lesson. But before that, we'll need some new variables. So let's go back to the start of the script. And let's introduce a public variable that will be of the type GameObject, and we can name it score. Another variable will be private, and that type will be text mesh, and we can name it score text. The purpose of the first variable is to select the score GameObject. And the purpose of this second variable is just to make things easier for ourselves. With this variable, we'll be selecting one component of this GameObject, and that component will be the text mesh component. We can see it also if we go back to our Unity and select our score GameObject, and this is the component that we want to select. The attribute that we want to edit in this component is the text attribute, or this one. An important thing to keep in mind is that this attribute only takes strings as parameters. Strings are basically alphanumeric text values, while integers are only numeric values. This 0 might look like an integer now, but trust me, this is in fact a string. So to handle this properly, first we'll need to convert this string to an integer, then increment it, and then convert the whole new number to a string in order to make it fit into this text attribute, since it only takes strings. I can demonstrate that for you in a few seconds. Go back to the script for now. Since this variable is public, we'll be selecting it by dragging the GameObject into the script tab in Unity, but we need to select this one now. In order to do that, we'll need the start method again that we deleted. To reintroduce it, simply type private void start. Once the script loads, we want to point this to the correct component. So score text will be equal to score, since we want to select a component from this GameObject, dot get component, and the component that we want to get, of course, is a text mesh component. Make sure you open and close the brackets since this is a function. And don't forget the semicolon, of course. Now that everything is ready, let's scroll down to the bottom of our script, where we made place for our code. And let me demonstrate why we need to convert it from string to integer and then back to string from that integer. We want to edit the score text, which is a text mesh component, and let's see it in Unity. So this is this component, and the attribute that we want to edit is the text attribute. So go back to the script and type score text dot text, indicating the attribute. That equals to that same number that we have, which is 0 at the moment, plus 1. Let's save this and see how it actually works. Go back to Unity and select the player GameObject, then scroll to the bottom to find our script. We can see that the score is not attached yet, so let's go ahead and change that. If we click play, we can see what will happen once we collect the star. Okay, so instead of incrementing the score, it just adds 1 to the text of the score, which is not exactly what we wanted. That's the reason why we need to do these conversions. First off, you'll need to convert this to an integer, And in order to do that, simply first put it into brackets, since that will be the parameter, and the function will be written in front of these brackets. The function for conversion is system.convert.toInteger 32. Now it will work fine in a sense that it will be correctly adding 1 to the number. So if we have a 0 here and add 1, it will not be 0, 1, but this time it will only be 1. However, we are getting an error here because this only takes string as a value. Because of that, we'll need to convert this whole number that we got to a string value. And again, it's the same procedure. First put it inside of brackets, and in front of the brackets write system.convert.toString. And everything should be working fine now. Go to File and click on Save All, and go back to Unity. We don't need to attach the score in the script again since we have already done that, and we are ready to test it out. That's it for this lesson. We have completed our goal, and the next thing that we need to do regarding the score is to make a game over screen and display the score there as well once we fail, and also make a high score system that will be saved even if we exit the game. And we will be doing that in the next few lessons, so stay tuned.